Right, recording in progress. The event loop videos, I think the most, let's say, short one and maybe to the point is the one of Java Brains. So I think it's a good idea that we start the class with looking at this as a group and then maybe use that as a sort of, let's say, base to go over what is the event loop exactly and how it works. So I'm going to start the video. Maybe I'll pause somewhere during the way just to touch on some things, but yeah, let's watch it together.
Queue is with synchronous events. And once you get that, you will easily grasp the async events as well. JavaScript is primarily single-threaded. It means that there's always only one thread that does all of the work that needs to happen in a JavaScript runtime. Yeah, I know, there are a bunch of exceptions to that, like worker threads and native stuff, but its application execution is just one thread, okay? So if you load a page in a browser and that page executes a few JavaScript functions, there is one JavaScript thread that's executing it all. That's a difficult job for that poor thread, isn't it? Take the example of a restaurant with just one waiter. I mean, imagine the life of that poor guy. There are a few guests in the restaurant sitting at various different tables, and this poor waiter has to provide service for them all. Now, how does he do it? If the events are spaced out, he has no problem. Let's say the first guest asks for his attention, he goes to her table and answers her question. And after he's done, the second guest raises their hand and he goes to that table. No problem, right? Now, what if it's a crowded restaurant? The first guest raises her hand, he goes to her table, and while he's answering the question, the second guest raises his hand. What does the waiter do? He doesn't immediately stop, of course. He makes a mental note to go to that table after he's done with this table. Another guest calls him, he adds that to his mental note. And then, once he's done with a certain activity, he goes through the list of things he needs to do in his mind, and he does them in order, first come, first serve basis. This is it. This is really what the event loop is. Since JavaScript is single-threaded, there is one thread that executes everything that's on this page. Now, let's say the user clicks a button that runs code that, calculates the 1000th prime number. The user clicks on it, and the thread is off doing its thing. But then the user immediately clicks another button. Now, what does the thread do? Does it drop what it's doing? No. It makes a mental note that it needs to execute that event. Another event happens, it makes a note of that too. And once it's finished this long-running task, it picks the next thing it had to do. The thing that it's using to make note of the events that are happening when it's busy, this thing is called an event queue. It's a queue of events, so what else are you going to name it? It's first in, first out ordering of events. It's an event queue. Now, whenever the single execution thread is done executing whatever it was doing, it goes through this queue of events and executes them until the queue is empty. You can think of the logic as something like this pseudocode shows. While the event queue is not empty, pull out the first item from the event queue and then execute it. This is a loop that looks at all available events and executes them till there isn't anything left. Yup, you guessed it, this is the event loop. So basically, the event queue is like a to-do list for the thread, and the event loop is the thread continuously checking this to-do list and doing those things until there isn't anything left. If the queue is empty, it goes to sleep. But once an event gets into the queue, it wakes up and does this thing all over again and again and again. Now, let's examine this particular executed step. When the thread picks up a function to execute, it can be either a simple one-step function or it can be a complicated one that calls some other functions. Now, if there are multiple functions, what happens is dependent on whether those are synchronous or asynchronous functions. Take the waiter example. The waiter picks up an event from the queue and it goes to the table. Now, the person at the table starts giving him an order, but then midway, she checks with her companion at the table to ask what he wants. Now, the waiter is not going to say, I don't have time for that, I'm going to head out. No, the waiter has to wait until the customer completes giving the order. This is blocking, this is synchronous. The waiter waits until the last question is answered and the order is fully given before moving on to the next thing. Similarly, when a single thread picks up an event and that event happens to be a function that calls another function which calls another function, well, the single thread has no choice but to follow that stack of function calls until the first function has completed executing. This kind of nested function calls is usually managed by most runtimes using a stack data structure. JavaScript does that too. It uses something called a call stack to do it. So here's a slight change to that simplified pseudocode. While the queue is not empty, it pulls out the first item, but then it follows the execution logic until the call stack is empty.
It's important to know that the call stack is something that JavaScript controls, and it's its way of JavaScript to know where did I start and which function did you call this task started from. So this, let's say in this example, it was function A, B, function A calls function B calls function C. It puts it in a stack on top of each other, so it knows where it has gone. So what the steps it has taken to go from that first function to the last function and to go back, because it knows, oh, I ended up now in the last function. I'm starting to do stuff. And as it is doing stuff, it's going to throw them back away. It says, okay, I'm complete. I've completed this. It can be removed from the call stack again until it's back empty. And when that is done, it will communicate to the browser. So the thing that is around the JavaScript, and that will manage the event queue. So the event queue are tasks, and these tasks consist possibly of multiple functions. So it's good to know that the event queue is managed by the browser, so around the JavaScript, and the call stack is the JavaScript, we call it the runtime, so the engine. So, and that is a big difference, because the event queue are the task and the call stack is every task for itself, just a little thing. The browser hands over these tasks, they're all getting stacked up in the stack, and it gets back done. And when it says to the browser, I'm done with this, we go into the event queue to the next task. So it's good to know that these are like separate things and they communicate with each other. Okay, I will mute.
The call stack, that there's really no action in the call stack. Is it like you can trace of like this function called this function and this one called another one?
It's both. It's also, let's go to.
So this is your call stack. Is it possible on the? I mean, if you want to do it, so I was just.
Yeah, no, go for it. No problem.
So you have a call stack which starts.
Oh yeah, wait.
Visible for everyone.
I need to stop sharing. Boom. All right. So now.
So. Let's say we have a simple program that has a function A. Is this readable or be not readable?
Small.
So we have a program with a function A that takes two arguments, sums them and returns them, right?
Yeah.
Then we have a second function, a function B that takes also one argument. Then it calls function A with twice its argument, right? And it returns that one. And then we have a function C that takes no arguments, and it calls function A with 2 and 5, and then it calls function B with 7. And our program just calls C once. Is it more or less reasonable? Yeah. Okay. So when your browser is going to execute this, it will first say, okay, this is declaring a function. Okay, this is declaring a function. I don't need to do anything yet. This is declaring a function. I don't need to do anything yet. Of course, the function becomes available to the browser, but you're not actually executing it. Here it sees for the first time, okay, I'm right here at line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It says, okay, I'm currently at line 12 and I'm going to call function C. So it's going to create what is called a stack frame. don't need to worry too much about the details, but it's going to add like a new box up here that says, okay, I'm going to call C. I'm going to put all the arguments I used to call function C, which in this case were none. And then it's also going to say, once I am done executing this function, I need to go back to the line where I called it, which in this case was line 13, I think. Let's think about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, if I can make it with it. So it knows once I'm done doing C, I need to jump back to line 12. Yeah. So what happens? We go to function C, and we see the first thing I do is I call function A with the arguments 2 and 5. Yeah. So once again, you're going to execute the function. So we create a new stack frame. Now, in this case, we are going to say, once I'm done, I need to get back to like my current line, which in this case is line 9, right? So I'm saying if I'm done executing line 9, I need to jump back to line 9. This is the return address. Yeah? And of course, I call it with 2 and 5. So I'm going to write both numbers in here as well. I'm going to say for argument X, it was 2. For argument Y, it was 5. Yeah. Okay, so now actually we can jump to A, and here we say, okay, what am I going to do? I'm going to return the sum of X plus Y. Now, this X in the stack frame, we can see, okay, it's 2, so far so good. The Y, I can see in my stack frame, oh, it was 5. Great. I return the result. Yeah, so I return the result. Then we say, okay, function done. Great. What should I do next? Well, if the function is done, we go see what was my return pointer. And it says, oh, once you finish, you need to go back to line 9. So function done, we can remove this from the stack. No longer necessary. And we know because of this set, you just finished line 9. I go back and say, okay, now I can go to this line. Here it says, oh, I should call function B. Great. So what do we do if we call a function? Yeah, so we create a new stack frame. We're going to say, okay, let's call function B. Function B takes one argument, Z, which is 7. I know it's difficult to read, but this is a 7. So 7 and what else?
5. Can't see it.
Yeah, so indeed. So the line. So here we say, this is where we call function B. So we say, okay, once we're done, the return pointer should be 10, right? Okay, so then we start executing function B. Great. The first line of function B says, call function A. So what do we do? Yeah, so we create our stack frame and we're going to say, okay, let's call function A. What do we need to put in the stack frame? Yeah, so the line is say
X, which will be the return of the function A, so 4. 7.
So yeah, so this here is the result after we call the function, so we can't know that yet, right? So what we do know is indeed the 2 arguments we pass, which here is z, so there will indeed be a value for X that we need to fill in, a value for Y that we need to fill in, and the line is line 5. And here for X, the first thing we pass was the variable Z, so we can look in our stack frame, the value for Z was 7. So we have 7, 7. Then we actually execute the function. Here it says return a value of X plus X, which X is 7, Y 7. So the return value is 14. Okay?
Okay, sure. So on line 5, the both arguments are set, not 2.
Yeah, no, it's set, yeah.
Okay.
So indeed. So this function is done. We can pop the stack frame, and we go back to line 5, because that's where we call the function, right? So we pop the stack frame, and we know now how we can go back to line 5, because that line is now done, and yeah, we add x here. It's not entirely true, but for now we can say we add x here, so now we have an x there of 14, right? Then we get back to this line which says, hey, this is the end of the function, you can return. So how do I return? Yeah, to return, we can once again pop the whole frame and go back to the line that is set here, which then points towards B. So towards this function, this is done. So we're at the end of the function again. So we say, oh, let's pop this. We go back to here, which was the original entry point of the program. So we reach the end of our code and we say, okay, return. We go look at the stack and we see, hey, I would like to return to the point I came from, but there is no more work left to be done. So at this point, like our coach said, the browser will hand over, like JavaScript will hand over to the browser and say, okay, give me the next event to work on. So this stack is really to resolve like how you jump from a function to a function, but still always return to the right place. And so you also never misuse like your variables. So they're always related to the right call. But more of that will be seen in the exercises as well. And I can.
Thank you.
So this is all synchronous because it always jumps back to the last point, adds new stuff, goes back, all happening like one step after the other. But more on that.
Yeah, we will go to the asynchronous thing and how this is working with it.
What if there is like, I don't know if it's possible, but is it possible to like jam a computer with
Yes, you know the website Stack Overflow?
Yeah, they just
Yes, the Stack Overflow website has its name from this kind of concept that you put too much in the stack and it says, gives you an error that says Stack Overflow. So this has a sort of maximum of kind of things you can put in it, and you go over that, then you get a Stack Overflow. So Stack Overflow means you've given me too much, I can't compute. So that's where the website got its name.
So imagine if you have a function x, and in the function you say, hey, let's call this function x. If this is your program, so you have just one function x, and the first thing you do is call function x. What will happen? You create the stack frame and you say, oh, once I'm done, let's go back to line 5. Okay, great. What do we see here? Okay, we're going to call function x. So let's create a call frame, and once we're done, let's go back to line 2. Okay, or what do we see in the function? Oh, I should call x. So what I do, add a new stack frame.
And it keeps on going.
I forgot the stack frame. And this will then keep growing until you're out of memory, and then you will indeed.
Yeah, there's a hard memory limitation on this, but don't worry about that, because if you're reaching that, you're doing something very, very, very wrong. So this is not something that you go with your, like say, the normal function. That's something when you're creating heavy loops and you're kind of missing something that, if that happens, something bad is going on. So I don't know where we were. I'm gonna go back to the video. Wait, share screen. This one. This is not my screen. Okay, that's better. So the part that we just saw in detail, actually how it works, is what JavaScript is doing. And then when it's done, we go back to here, our event queue, and it picks up another thing. So this whole thing, this whole synchronous event is what one task in the event loop. So it's one block that says hello, but it can be small. It can be one function that just executes one console log, for example, and it's nothing. But a task can also be huge. Like we see, it can get quite big, quite fast when you're using all these kind of functions that are connected. And why that, and that might be a bad thing, and we will gonna see later why that is and how we can prevent it. But
All right, so this is how.
okay, wait, I have to do the audio thing again. Oh no, I was sharing sound. Oh yeah.
Synchronous events work. Now, how about asynchronous events? Let's take that single waiter restaurant analogy again. I don't know, it's empty. All right, so this is how synchronous events work. Now, how about asynchronous events? Let's take that single waiter restaurant analogy again. I don't know why people would go to that restaurant, but turns out they do, and they order food. The waiter takes the order and hands it to the chef. Now, does he wait until the chef prepares the food? No, he doesn't. The waiter handing the order of the food is an asynchronous event. He hands over the order and says, I'm going to go do other things. Call me back when the dish is done. And then he goes to the next thing that he needs to do in his event queue. Now imagine he's talking to someone at table 1, someone at table 2 raises her hand, and then a little while later, the order for table 3 is prepared by the chef and it's ready. Now, what does the waiter do? Remember, he's operating strictly in a first in, first out manner. So he adds to the event queue the table 2's request, and then the fact that he has to serve table 3's food. That's basically how event queue works for async. When an async call happens, there's often a callback associated with it. When that async call completes, the callback isn't immediately executed. It is put to the back of the event queue. Consider this example. First, the waiter takes the order from table 1 synchronously. He hands the order to the chef with a callback to say, hey, when the chef has finished the order, this dish needs to be served to that table. So the waiter doesn't hang around. He moves to take order for the next table, which is table 2. When he's in the middle of taking that order, let's say the chef finishes order 1. Now the callback doesn't get executed immediately. Nope, it goes to the end of the event queue so that the waiter can get to it once he's done with the current work first. So you can see how simple event loop and the event queue concepts are. This also explains a lot of the JavaScript behavior you see in browsers, by the way. Take the instance of when you have a browser tab which is hung because some function is running slow, and then you click on a button on a page 2 or 3 times. What happens? You don't get an immediate response, but then when that long-running thing finishes running, all the times you clicked on that button respond together after. See, JavaScript runtime remembers because every time you click that button, the handler got added to the event queue, and it all got executed by the event loop when that single thread was done doing whatever it was doing. There are a few applications and real-world strategies you can implement in your code. Button, the
So we've all been to websites where you clicked on something, some kind of form or something, nothing is happening, and you click it 5 times or 6 times, and you're just making it worse. This is why we do async stuff. The thing is, the browser, what we saw in the call stack, while that thing is going on in the call stack, there can no longer be any rendering. This is also maybe a time to go back to the boards for this and to visualize actually what is happening in the event loop. So let's say we have our JavaScript part here. Oh, this is not good. Oh yeah, I need to stop sharing again. Okay.
Yeah.
All right. So let's say we have our JavaScript parts here. We have our call stack at work. Let's say JS. The event loop, let's say a simple example. Somebody clicks on a button and something is starting to happen, like in the example that we saw in the YouTube video. Something is going to go on here. And as long as this is going on, let's say we have our browser here and our event queue. As long as stuff is going on here, your browser window is not going to be fresh. It's very important to notice this. As long as this call stack is doing all its stuff, calling all its functions, doing its thing, nothing gets re-rendered on your page. So how can we solve this? This is the async function that was used in the example as well, like the waiter, that he said, okay, I finished my order. I tell the cook what he needs to prepare. He's working on that. And while he's working on that, I can start doing other stuff. So what is it going to do? It's going to talk to, let's say, this is the browser. So browser. So let's say this is a long-running function. And at some point in the function, you're going to use an async thing. The JavaScript is going to say, hey, I have an asynchronous request for you. The browser is going to take it out and going to say, okay, I'm going to handle this for you. I'm going to take, you don't have to worry about it in your call stack. I'm going to handle it for you. And I'm going to make a thing in the event queue when it's done. And you can handle it again. So the JavaScript communicates to the browser. The browser kind of uses this task. It runs it in the background. It's not using the call stack. It's using its sort of own mechanism. And when it is done processing this, it's going to put it in the queue. And from the queue, it's going to go back until here, but only when it's finished. So in between, you have to know that after every task, the browser has the opportunity to render again. So this is kind of the loop that's going on. So the JavaScript talks to the browser puts things in the event queue. And between this, you also have, let's say, renders. We all know, yeah, let's say most of you have played some video games. You all know the concept of frame rate. You know the frame rate, like they say, a good frame rate is like 60 frames per second. And if you go way under that, then you get sort of lagging visualization. Your browser is kind of trying to do the same thing with a frame rate. So your browser is trying to give you 60 frames per second. So it's trying to give you like a steady flow. So if things are moving on your screen, they move in nice kind of things and they're not jerking, they're not blurring. But to do this, you have to keep the threads of all this process with very small tasks. So the longer a task runs, the less time there is for rendering. So the longer you block this, your browser is going to want to keep this cycle going at 60 times every second. 60 times every second it wants to go around, but every time it is working on this call stack, it has to say, okay, I didn't have time this frame to work on my rendering, I'm going to skip it. And I'm going to skip the next one if I'm still busy. And it keeps on going, it keeps on going, so the user has to wait, like in the example, when you click the button, until the task is finished to get to this point. So what do? We put it in the queue, so we get to a render, we get to a render, we get to a render. The task is done, we put it back in, and then we go to the same loop again. So, yeah.
And then the task is being delegated to the browser. When it goes back to the event loop, it's already resolved. And then when it goes through,
it is resolved.
The JavaScript is just like, boom, goodbye.
No, you still have to, this will still end up in here. So the render is something that happens also in, let's say, between this, but this task is going to go back in the call stack. It's possible that you, with an async function, it's important to know the concept of a callback. So when you execute your async function here, you attach another function that is executed when your browser is done. So you create a function, you say, let's say an API request. You're going to get some data from a server somewhere. You don't know what it is in your browser, you need to get some data. You don't know how long it's going to take, so you say to your browser, get me the API data. And you also, so let's say that an N plus, you give it a callback. So an async function is something that usually consists of two things. It consists of something, okay, I want you to go and do something in the background, and also I want you to execute something when it's done. And what you want to execute when it's done is what we call a callback. A callback is a function that you give to it, and you say, okay, you fetch me the API data. The API data is going to be a parameter in your function. So you're going to get the data, and with the callback, you can use that data to do something. So let's say I'm on a website that displays like sports results. The website itself doesn't know what all the results are. So it needs to go and get the API data, and you say once it's done, you go to this div and you put all the data in there. And I know what I mean? And that's the callback. The callback is going to be, okay, we got the data. Now you can do something in JavaScript with that data and manipulate something again, or go to the next step.
It would be like a component function.
It's just a regular function. It's just a function that executes right on the moment that your function is back. That's going to be resolved here again, back in the call stack.
Imagine, for example, you need to print the participation for paper that you give in the future. Like you could send an email to Gorilla and sit for 14 hours in front of your PC until Gorilla answers, and then once Gorilla answers, print it out.
Yeah,
but that would be really stupid. Like from your point of view, what's better is that you say, "Hey, I'm going to send an email to Gorilla." And you make a mental note. Once I receive the email from Gorilla back, it can be in 5 minutes, it can be 14 hours, she might be on vacation, but once I get the email back, I'm going to print it. But then from that point on, you're free to do whatever you want until you get the email back, and you just make a mental note. If this thing happens, and that's then in the queue, the browser will say, okay, the email is received, so now you can do this thing when you're done. But it's not that you receive the email, you drop everything, and you go home and print. Yeah. You're at work and you say, oh, I received the email, so whenever I am home and I'm free, I can continue with printing the email, because that was the thing I needed to do once I got the confirmation that I received it. So that's really the idea.
Yeah, because when it's done, it's possible that there are 5 things that are done at the same time. So all these things get in this queue, and it goes on and on and on and on. As long as this is busy, everything that is done, it gets in the queue. And the queue, like in the video said, it's first in, first out. So the thing that was the oldest item in the queue will be used first. So the one that's put in first will also be taken out first. So this is sort of a waiting line for when this thing is done with its current function, and then it can take another thing out of there.
The call stack is last in, first.
The call stack is also first. It's called of a different.
Yeah, but a stack is indeed like last in, first out, because you put stuff on top and you always take the top thing out.
Yeah.
And then
But I have one last question is further, because this is making me think of something I was struggling with in the work project as well. And so I was trying to render 2 different lists, right? But I use one object with 2 arrays. So I had one array for pending tasks and one array for done tasks. And I had to render from the array, I had to render the item with 2 buttons, the done and the delete task, something like this. So at the end, Khawila gave me the answer like use on clip and on the rendering, because you cannot use the listener. Okay, so that was something that I was thinking, what if I'm trying to render something that it depends on something else to be before? Like if I put, or maybe I'm not understanding well, if the browser takes longer to finish something.
The answer to that question you'll see a bit later on in the next video.
Yeah, I think he's talking about event doubling than async. It's more like event problem. You want to access a clip.
Something that is not there
Yeah.
still.
But now we're talking about event listeners, really on, you mean on like buttons or
Or I
links or
just
stuff
want
like
to
that?
get something that's still not there, like from the DOM.
But
Oh,
I think the question there is a bit different, and I think I will have a discussion with you in private, because it's not really related to this
Yeah.
thing right now.
That's okay.
And so I'll talk to you maybe in the week.
The main important thing to remember here is it's going around, it's a loop, in that it will always, if it's not working on something, it goes to sleep and it just waits for something to pop up and says, oh, I got him, and it starts checking it again. Also, if it says, oh, something changed, then I will go to render. It will not render every time, so don't think that every time it goes around in its loop, that it also renders. The browser is smart enough to know that something has changed or not. So it will only update if it knows, oh, you changed something to the DOM, now I have to do some rendering. But it does check every time. And you have to give it the opportunity to check it every time. And it's very important to know that the longer you keep the call stack busy, nothing is able to happen on your screen. And that's where we're going to use these async functions, and how they work we're going to see in a couple of examples. First, maybe clean this. Okay. So, let's screen share a little more. Seems my Zoom has disappeared. Oh, here it is. Share screen. Okay. Share. Maybe. Oh, is there a question? Oh, I see some stuff in the chat, but I think that's more about sound issues. Maybe first, does everybody kind of understood what was going on here, like with the loop that's going on and what it sort of is trying to manage? Yeah, all right. Then we'll take a look here at the first thing, the event loop.
Any questions online?
Oh yeah, online?
Yes, I have a question, please.
Okay.
Yes, it's about the event loop. I would like to know if the render rate is like an infinite loop, and how to stop the browser to render a call stack or a function that has already been run by the browser.
You mean if you created somewhere an infinite loop, how you can stop it, how you can interrupt the call stack?
Yes, please.
It's not really possible. The browser will most of the time notice that when you have run the same function for 15,000 times, it will notice that this is not normal, and it will give you a function like, you're creating an infinite loop here, I'm gonna shut down the tab, or do you want to shut down the browser? But you can't really control this with your JavaScript and say, okay. It's also weird because you would never kind of intentionally start an infinite loop and then tell the browser somewhere in the infinite loop that, okay, stop the infinite loop.
Yeah, but I wanted to know because the browser will run all the functions that are in the waiting queue. Now, if all the functions are already run, how to stop the browser to run them again? Because what she explained is that when the first function is run, it will go back to the waiting line, waiting queue, and will be rendered again.
But it will not be the same function. Eh? The queue will be filled with callbacks from that function or with other tasks. So it will not infinitely keep doing the same function. So a function can be triggered like when you load the script for the first time, or when you click something or stuff like that. Then a function can be executed. It will be executed once. And then when it's ran through the call stack, it's finished, and then it's gone, and the browser will just go to sleep again until you click the button again.
Okay. Now I see. Okay, thank you.
All right, no problem. Okay, I'm gonna show you guys some examples. The first one is, it's going to redirect me to something. I'm going to full screen this thing. Have all of you heard of the set time out function? Does this ring a bell for everybody? Like this thing that you see here on the screen? Sorry? It does that, but it also does something. It does it in a particular way. So, like you can see here, it takes 2 arguments. Like indeed, it gives it waits for a time. You can say how long it has to wait. So you have to give this number in milliseconds. But it also gives you the possibility to attach a callback. So this is the thing that I just spoke about, like with the async. So set timeout is something that you can use, is a very basic example of something to use to create an async function. So the first parameter here, so first we define here this function callback1. It's just a function, and then we do a set timeout with that function and 3000. So does anyone know what this thing on line 12? Can someone explain to me what will happen here?
Going to wait for three seconds, and then it's going to call that and say hello from timeout 1.
Yeah, can you kind of try it to, if you think about what we saw on the board later, can you sort of tell me how it will go in that way? Do you know what I mean? Where the function will it be attached to the callback, to the call stack, or will it go through the queue? Maybe a little too early.
Maybe before we go there,
Maybe just run it.
Can you predict which of those sentences will be printed first?
That's
Hello
also
from timeout 1, scheduled timeout 1, bonjour from timeout 2, scheduled timeout 2, or this one?
The last one.
You'd say this one is printed first? So can you say why?
That's my guess, because there is no waiting time for the.
But try to think also in the blocks. So first we define here a function, then we call that function, then we have a console log, then we have another definition of function, we have another set timeout, a console log, and a console log.
Will be 21.
So why do you think 21?
Because the other ones are going to wait in the
and what is the difference between 21 and 14?
Yeah.
Okay, tell me, what do you think? Why 21 first and not 14?
Yeah, you're right. 14
Okay, so 14 first, and then 21 second, 23 third is the guess. So what's the fourth one?
And then 19.
19, but 19 doesn't print anything, right?
Oh,
19 just says set callback. So
17.
So 17 and
finally 10.
And I mean, maybe we can run it and see.
Yeah, we will run it and see how it runs. So this tool will show us kind of what is going on in the background. So I'm going to go to the first step. So you see here in the task queue, we have this thing for callback 1. So the task, so this is from line number 12. So in line number 12, we have a callback defined, but it's an async function. So we're telling the browser, do this after 3 seconds. So you can just hold on to it for now. And then after 3 seconds, you can put it in the event queue, and then I will pick it up again. So also this is sort of important to know that it will not, 3 seconds is the minimum time that it will take, because you don't know when it's going to be picked up in the event queue. So never use set timeouts to say, okay, I want to know. It will never be exactly after 3 seconds, because it can be that you have maybe 10 of these set timeouts, and if they all kind of come in at the same moments, it has to choose which to do first. So this is sort of a minimum time that you attach to it, something just to keep in the back of your mind.
So that delay also, the delay also stops.
Yeah, exactly, because in the task queue, they will all get it the task queue, and the browser says, okay, 3 seconds are over. Now you can pick it up, but if it's busy, it can't pick it up at exactly that time. So it's possible that more time goes on.
So actually, the set timeout register the callback there, and it also say don't pick this task if 3 seconds haven't passed yet. So imagine that we stop here directly, and now there's no more stuff in the stack. So it tries to get the next event, but the next event says you can't execute me before 2 seconds pass. So it's not going to take that task yet. So it's going to take the second task until at some point it wants to look at the first task, and now it says, yeah, enough time has passed, so it's going to take it. So even though you say wait 2 seconds, the browser isn't going to wait 2 seconds. It's just not going to do that specific task until at least 2 seconds passed.
Yeah. So the next step then, so nothing really has happened. We just have put something away so that we are waiting for. So the next thing that is happening here in the top right corner is now we get a console log from line 14. So this is something that just can be processed by JavaScript. It doesn't need to go to any other functions. It can just run. So it will execute and it will give a console.log. The second thing here, we define a function callback2, and then another thing is added to the task queue. So we have now 2 callbacks that are in the waiting area, and we can go on with our next step. So the next step is again a console log for this one, and it will say the call stack is empty. So we now went through the entire script. So now the call stack is empty. It can render, it can go through the task queue again. The loop is free, so we are not blocking the main thread anymore. So now the next step, what is the loop gonna do? It's gonna check, oh, is there something in my queue? So the first thing that will be back is the shortest one of the timeouts, because yeah, this is not gonna take as long as this one. So it's gonna first say bonjour from timeout 2. It's going to put this on the call stack and process it. Here you go, bonjour from timeout 2. And then it's again free to do its rendering and all that stuff. And it goes back to the next in the queue. And there we go. And we have our last console log. So this is the difference between the synchronous and the asynchronous stuff. When it's synchronous, it's just one by one. It's blocking everything. When you do async, you're using the queue and you're just saying, hold on to this task. And when it's completed, then we execute this callback. So what we see here, the callback 1 and the callback 2, these are the functions I'm talking about. These are stuff that when they're done and when you have time to pick them up, I want you to execute this function. That's a callback. All right, this was example 1. Let's do one more, right? What do we have here? 0 delays. Maybe again, also I'm gonna check. Yeah, does somebody want to go for this one again and say what they think, which console logs will be executed in which order? Can everybody read this, by the way? Yeah, you can make it a little bit bigger. Yeah. Anyone feeling?
It seems that 19 will still execute first.
Why do you think 19? What is the difference with 19 and 16 and 9?
Well, it doesn't have a timeout on it. It's just going to, as soon as the code proceeds for
Yeah, you're correct. It would be 9 because 9 is also simply a console log. There is no difference between, yeah, 9 will be the first one to execute. This is the first thing that you encounter that is just executable. This is a function definition. Nothing happens here. You're just assigning a function to a variable. It's not, you don't have to execute it. Console log is an execution. A return of something is an execution. But this isn't a set timeout. It's an async thing, again, a definition. So it's kind of comparable with the last exercise. So first this console log on line 9, then the one on 16 and the one on 19. And then we have 2 timeouts and they're both set at 0. So what, yeah. Sorry?
The functions are not being called exactly.
No, they're not called directly, but you can see they're passed here as a callback in your set timeout. So we're going to say when at least 0 microseconds have passed or milliseconds have passed, call function 2.
Okay.
So what you will think will happen if we put 0 in here? Because in the last example, we said, okay, wait 2 seconds or wait 3 seconds. And now we're just saying 0. So like, what will it do? Yeah, but you say it will, do you think it will be added to the queue or just execute it immediately because it's 0 seconds?
It will add to the queue. Actually, I have a question.
Yeah.
Who decided that set timeout go to task queue instead of go to post stack?
That is the async, let's say, nature of that function. The function will always create a callback. It will always do something asynchronous. So it will always put something in the queue because it's an asynchronous function. Only synchronous functions that are handled at that time will be put in the call stack. And an asynchronous function will always be delayed. It doesn't matter how long or.
So we need to find out the asynchronous functions like set timeout or.
Yes, the set timeout, it will.
Functions.
Maybe it's good if I open up MDN and I just show you what the specs are for set timeout. Then you can see how the function is defined. So set timeout is a web API function, so it's your browser knows what it does. It doesn't want to load. Oh, there it was.
The timeout, we're using here set timeouts to show you the asynchronous way of.
Maybe this window is called.
So there is basically 2 kinds of functions, at least 2 kinds of functions, normal function and asynchronous functions.
Synchronous and asynchronous functions. So the synchronous is just the console log that's coming right away without any delay. And the asynchronous is going to go somewhere and grab a data or whatever, and it's going to come back. So it will take time to process that. So
if the asynchronous function has the schedule to perfect, even the set timeout, the time is 0, it will still must go to the task queue first and then go out and go to post stack.
Exactly. That is what we're trying to show here. Okay, this is the wrong example. It's this one then. Like that's exactly the point with these timeouts. It doesn't matter what the time is. It will always be taken out of the normal flow and put in the task queue for later. And later will be very soon because you put in 0 and you say actually put it in the queue and take it up. Put it immediately in the queue, because with the last example we saw wait 2 seconds and then put it in the queue. So that's the difference between the last example and this one. Here, yeah.
There's the event queue.
Sorry?
I say that from the YouTube there is event queue, but from this exercise there is the event queue.
Oh, it's a task queue.
That's the task queue.
It's a task queue.
So
You can
event
call-
queue, task queue is the same thing.
Yes.
Yes, the wording is sometimes used differently in sort of, some people talk about tasks, but you also have, I think they also sometimes call it maybe other things, but it's not going to be always exactly the same wording, because also every browser has sort of its own implementation of this. So it can depend on which browser documentation you use in the way they describe, because Node.js has also kind of different way to describe all these things. So you can find different sort of wordings for these things, but generally, if you say task and task queue, it will be clear kind of what it is. And I think it's better to say task than event, because event is more like you click on something, something happens, but a task can also be run when you just open your page for the first time and the JavaScript just is loading for the first time. That's also a task. You can just create a function that just loads when your page opens. That's also a task, but that's less obvious that that's also an event, I should say. But yeah. So yeah, let's run this example as well. Just see what is going on here. So the first one to go is, yeah, the scheduling timeout 1. We put here on line 10, we put callback 1 in the queue. It gets added to the queue immediately. There's no waiting time like in the last example. Then we get the next console log. We put the second callback in. So this example is actually the same as the last one, but only the browser will not wait a kind of time before it puts it in the queue. It will just say, okay, immediately go to the queue and execute it after this function. I think we can do another one here. Let's say passing arguments.
So if you look at this, do you have any reason why you would ever use the timeout 0? Like, why would you use it?
It's the type, but we don't, maybe there's something primary already. We want something, we definitely want something happen before they come out. Not this kind of.
But then why wouldn't I just cut the code and paste it after the code I want to happen first? If it's just about I want this order thing to happen first.
I don't have experience.
No, it doesn't matter.
You were really.
Yeah, the thing is, maybe think about like an animation for something. Like maybe you're trying to move a block around on your screen. I don't know if this is helping you in trying to figure out why you would maybe use a set timeout in a function like that with 0. Yeah, exactly, because you want to force the browser to render something between, because if you do it synchronously and you say that the block starts at position 0, 0, like X, Y, 0, 0, and you want it to go from that point all the way to the downwards of your screen. So you're actually saying, I want to go every step, let's say -1 on the X and -1 on the Y every time. But if you do this in a synchronous function, it will just start here and it will go to the bottom of your screen, because it doesn't care that you just do everything minus, because you're never rendering in between. But if you do these set timeouts, your browser has the time to recalculate. You're putting them on the queue. So you do a -1, you said, okay, do a timeout of 0. It's on the, I can render. It goes 1, -1, -1. and you put it back again on the queue, it can render and it goes again. But if you do it synchronously, you will just end up straight away at the end of your screen.
Okay, is there a huge difference? There's
Yeah.
render between these days.
Yeah, it's stuff like that when you want. Sometimes you don't want this. Like if when you create an element, and let's say you create a button and you give it some with JavaScript, you just say like document.create element, and you create something and you give it some styling, like you say, give it a background color, you give it a label. You don't want to set timeout between it because it will then go to the DOM every time, but you want to define it in one piece and then ship it to the DOM in one time. But with the animation, you want to keep re-rendering. So you have to know when to use what. Sometimes you want it synchronous, sometimes you want it async. It depends on your use case. So they both have their uses, of course. Just have to know why are we using the task. Let the task queue work for you. Use it when you need it.
For animation, this.
Yeah, you can. There are better ways to do this, but it's like to give an example, because set timeout is considered most of the time a little bit hacky to use. So it's sort of a way. We will see later, I think, a request animation frame. I don't know. If this isn't the course. That's more advanced. That's maybe if you're interested, it's Google it sometimes, and that's actually the better way to do it. All right, another example. I'm gonna just see what it does. Oh yeah, this is a callback where we're gonna pass parameters to. So I will run it and kind of show you how this works, but I think it's kind of clear what will happen here, no? What will we see popping up? Which console log we will see two console logs, and which ones will we see? Sorry?
The one on line 9.
The one on line 9, yes, and we will see another console log as well. And what will it say? But line 7, again, this is the timeout that says, okay, put something in the queue. And then after 5 seconds, another console log will happen with the callback online, with this callback. And what will be shown then in the console log? Because this takes 2 arguments. It says console log, arg1 and arg2. No IDs? Okay, let's find out then.
Will become one further, arg2 become in callback.
Yeah, absolutely. This is.
But I don't know why and how.
Yeah, this is kind of, set timeout takes also 2 parameters here to put in. These will become these, but it's maybe. It will say goodbye in the end. You can give parameters to this as well. So it will first, of course, print the call stack is empty because we have put this on the queue, and we're going to wait 5 seconds. Yeah, we have not put it on the queue actually. We're waiting 5 seconds and then we're putting it on the queue. So that's important to know that difference. So 5 seconds. Next step. The task gets queued and then we see goodbye in the end. So it's not because it's a callback and you're trying to execute it in the future that you cannot give things with it at the moment that you're kind of initializing it. Yeah, I think also kind of a good example to do the call stack is in here. So just to recap on what we saw in the beginning with the we explained here on the board with the call stack. This is this in the JavaScript visualizer. So if you run this, you see we define a lot of functions that call all these other functions, and let's step through them to see what happens in the call stack. So the first thing that actually happens, because nothing really, nothing executes here. We're just defining what happens in these functions. We're just executing the first time here on line 21. So the first that happens is, okay, the call stack says, okay, I'm starting on this first function. The first function says, okay, you have to execute the second one. So, okay, we add it to the call stack. And so this whole thing keeps building up. So we go from all these functions up until the last one. And in the 10th, we see just an empty execution. But at this time, it knows, okay, I'm at the end, I'm executing stuff now, I can make my way down again. I'm going to start executing all these in the right order. And then we're going to go back down. So we just come back to the place that we finished. So this is the call stack. You can play with this stuff as well.
Can you go to the previous
Want to go back to the previous one? Yeah, sure. This one?
This is the syntax is confusing there because the arguments for the callback function are not written like you would expect them to be in the brackets after callback.
Yeah. And what do you think would happen if you put them in the brackets after the callback? What do you think that would do?
They would take 5,000 of the first argument.
Because if you actually, like, if you say like you do, if you were to put parentheses here and say goodbye, like you would do, like a function call.
What do you mean, like this?
Yes. So this is how you would expect it, right? That
Yeah.
you told me.
Yeah.
So what would happen if you do it like this?
I'm not sure.
Well,
Value.
you simply wrote a function call in here, so it will call the function and will then get a result, and it will try to schedule whatever is the result of your callback into the event queue. So that's why we can do it this way, because this way you're actually telling JavaScript to call the function callback, which will give back a result. And now you're saying within your set timeout, you're saying the result I got back, please schedule that one. And that result will not be a function, so JavaScript will probably complain.
If we do it this way, you can see it immediately gets added to the call stack, and it does not go to the task queue.
Yeah, that 5,000 doesn't do anything.
Yeah, if you open the what is it called in English? It's parentheses. Yeah, my parentheses like this, you're immediately executing. And a callback, you don't want to. You want to execute it when your task is done.
If now you go to the next step, it should give an error, probably that it cannot see. It says type error invalid callback, because you say as a timeout, you always have to pass a function that can be executed after those 5,000 milliseconds, right? But now the result of callback, it doesn't return anything, so it will just be undefined. So it'd say, hey, you want me to schedule undefined, but I don't know how to do undefined, so I'm just going to complain. Is it clear why they made it clear?
Clear, it's just different.
Yeah, I know.
Yeah, but don't break your head on this too much yet, because we're going to promises later on, and then it's going to be a nicer way to handle all these async. This set timeout function is sort of a way to simply introduce you guys to the idea what an async function is. Set timeout uses a callback in this way, so you guys see, okay, it's getting first handled to the browser puts it in a task queue, and then it comes back to the thing, and between that we can do renders, and we can make sure that
I also have a question. In the previous one, good and bad will be one, two, three. The third and fourth argument of set timeout is that the syntax of set timeout, from the third one and
yeah, exactly.
it will be the passing as argument for the callback function.
Yeah, exactly. So everything you do, like past the milliseconds, will pass the arguments in the same order. So if you have a function with 7 arguments, you can just put 7 arguments up to the 5,000.
Yeah, this is what they're called, like, it doesn't matter how many you put there. It will just take everything you put behind there, and it will assume that you want these as arguments. So if I only use one here, let's say I do hey, and then I do three or something like this. I don't know, it doesn't really matter. No, I need to close this here, run it. Takes a little time. Okay, let's go to the step. So this time it gets added to the callback queue, to the queue. The task stack is empty, is the first one we log. Then we come back to our function and we see here, yeah, okay, my thing is in the way here.
What is the from line 7? What is there's usage dot there's some a bunch of
it doesn't matter how many, it depends on your callback. If you want to have 7 parameters in your callback, you can give as many here as you want. I just mean
the callback every time, and the callback only takes 2 arguments, but the in the set time out there is a dot arguments like that kind of thing.
Oh, with the dot I meant you can just put in as many as you want.
Yeah, there's a lot of like items can be passing as arguments in callback.
It depends on your function, the function you wrote, the callback function. How many arguments does it take?
Yeah.
Only take to will the function will the callback function be called again for the second time or the third time until
No.
all the arguments?
No, it's only call it once and pass all the arguments.
Yes.
Yeah.
Okay.
So if you provide too many, they will just be ignored.
Yeah, exactly. If I just do this, wait, let's say edit, and I just take one argument here, it doesn't matter. The way it's set up, set time out doesn't know how many parameters there are in the callback. So it just accepts as many as you want, and it will just pass them through to your callback. And if your callback only accepts the first one, yeah, fine. It just throws away all the other ones. So if we do this, yeah, it will not know, sorry, it will not know all this shit. Edit, yes. Work. So this will keep working. It doesn't matter how many we put in here, it just will say, hey now. Okay, step, go. You see? So it doesn't matter. It doesn't want to handle them all or something. It just says, okay, you only want one, fine. Then I will throw the other 2 away. Let's say it like that. Okay. MDN is not working for me. Oh, it was there for 2 seconds and then it disappeared. This is weird. Maybe I'll just try it somewhere else.
I'll share with you on Discord as well.
Okay. I'll try in Chrome. Maybe it's an issue there. Ah, this works. Kind of. Is everybody?
It works on
It works.
Okay, then I'm doing maybe some.
I will share, maybe.
No, it's not a problem. Is it just a problem? Whoa.
There you go.
Oh, now it's working. Oh no, that's you. Okay.
So we can see it here, or you can see it through your.
Oh yeah, like this. Yeah, you can always go back to these MDN docs and just see how the things work. Set timeout is, I mean, it's a predefined function. We don't decide how we use it. You have to use it the way it has been designed. So you can see here that also on the first line here. Oh yeah, we don't see it here. Right? Yeah, it's complicated with all this sharing. It's, Yeah, we can see in the document that it takes as many arguments. You will also see this 3 dot notation coming back. And what I mean is it can just keep on going. That's sort of the thing they want to say with that. All right. Any questions so far?
Is the square bracket.
I mean, you can use the, what do you mean? It's a different.
So in the example, we saw fallback, comma, the delay, comma, the argument. Here's different.
It's different? It shouldn't be different.
It's the delay and the argument.
The function you see.
In the bracket, then that means it's optional.
Yeah.
Yeah, so indeed, so that's how you have to read the documentation. The function is before the square bracket, and that just means the function is mandatory if you scroll all the way to the syntax as well. So the only thing that the square bracket means is you shouldn't actually put this in your code because it will crash. This is just a way for the documentation to say whatever's between those are optional. So you are allowed to pass a delay, an argument, and a second argument, and an infinite amount of arguments. But if you don't provide a function, it will actually crash. So the function is not assigned to the square bracket. But that's just how Mozilla designs their documentation. So you don't need to actually put a square bracket.
Okay.
Okay. Any other questions yet so far? No? All right, great. Questions from the people online, maybe?
Online, can you hear us? Are you with us?
Right. Okay. And I think we can go on to the next parts. I just mentioned a little bit before that there is an easier way to handle this kind of asynchronous stuff. And it is what we call promises. How can I share the screen again? Share screen, yes, okay, share. Maybe I'm thinking a promise is sort of a way that we're going to handle these async things. So right now what we have seen, set timeout is handling this for us. So we just give it the callback function and it will kind of do this promise thing for us. A promise is something, if we go back to the restaurant example, a promise is that the waiter, it goes to the kitchen and the cook, and it says, okay, can you promise me that you will make this food? And he will either do it or he won't do it. And so a promise can resolve in 2 different ways. It can either resolve, which means, okay, I have done something in the background and it's been successful, and here is the result of it. Or in the background, something has gone wrong. Here is the error for it. So there are 2 possible sort of ways a promise can end. A promise always starts with, let's say you create a promise, it's in a status of pending, so it's waiting for a background task to execute. And then there are 2 possibilities it can resolve. So it's a positive outcome and you get a result, or something goes wrong and you get a negative outcome and an error. So that is kind of the way you're thinking about it. I'm going to show you guys also the classic kind of way here to create a promise. This is how we create promises. And oh yeah, I'm late, of course. I think this kind of readable. Maybe I'm in front of it. Better wait, I will go a little bit up. So a promise is a thing that your browser will know. It's sort of a class that you can create a new instance of. So that's why you use the new thing. You create an instance of a promise and you give it this function, which is the callback, and then you can either resolve it or you can reject. Now you see here that this is a very simple example in which we just do synchronous stuff inside of your promise. So we're just logging something and we resolve it ourselves. Most of the time, there will be a resolve and a rejected thing in the same sort of promise. Like here on rule number 12, you see a reject. So inside your promise, you can use these two functions, and you can add something to them, which will be the result that you catch here in your then. So a promise always has you create it and you give it a callback. So kind of the same as a set timeout. Instead of set timeout, you're using new promise. You're using a new promise, you create it and you say, this is what I want to do inside of my promise. This is my background task. In this background task, you can either go, it can go good, you can resolve it, then it will end up here in your then. So then is the positive outcome. And this is sort of, I will explain later how the flow really goes. The then is the positive outcome, and the callback will be resolved, and the val here will be this success string. So whatever you give as a parameter to the resolve function will end up as a result in your then function. Whatever, yeah, exactly. That's a positive return. Like you say, okay, I did my task in a good way, it's successful, so I resolve it. I say, okay, this went good, here is the result. But if now we take a look at the rejected promise, it's a reject, and also again the same system. You can give it a parameter, and that will be handled in the catch. So you kind of see how this async thing works. So you give a promise, you execute it in the background. If it comes back successfully, the callback will be handled in the then. Yeah, actually, yeah, you can do both in then, but let's say the positive thing is in the then, and the negative, if it goes bad, there's an error, you will catch it, you will catch the error. So the thing here, the resolve executor and the resolve success, that's a thing. If you're going to use this promise, it will be the background task that runs. And once it's been resolved and the resolve function is called and the resolve function is back in the call stack, then you can go on to the then. So the function you put in here is the callback like we did in set timeouts. So here on line 6, this is, so set timeout doesn't really have the, if it goes good or it goes bad. It just has one callback. Here you can have two, one for if it goes good and one for if it goes bad. And I think you want to explain.
So also really cool here is that you don't provide the time. So however long it takes, that's how long we wait. But as soon as the task is succeeded, so as soon as it's resolved, then we can do the next thing with the day. So I'm just going to give an example. So if you think back about the restaurant, where you go to your table and you take the order, then you go to the kitchen and you tell the chef like, hey, they ordered these things, right? And as soon as the food is ready, we want to do something. So if we haven't seen this kind of, if we wouldn't have seen this kind of promises, what we would have done is we would have said like, okay, yeah. Oh yeah. So what we would have said is like, okay, we go to the kitchen. So let's imagine that this is like the kitchen. And we say, okay, this food needs to be ready. Up until this point, we've only seen set timeout. So what we could say is, we could say, oh, in 1 second, please go check if the food is ready. This is something we've seen before. So we could say, okay, let's wait 1 second, okay? So nothing's happening, 1 second passed. We see the next task is, oh, please go check in the kitchen whether the food is ready. So I can go to the kitchen and I can say, hey, is the food ready? No, the food isn't ready. It takes way longer than 1 second to prepare food. So I make a mental note, okay, I'll come check again in 1 second. So I make a new task, wait 1 second, you see, and I could keep repeating this until the food is actually ready. But I never know like how long it's actually going to take until the food is ready. So using this way of kind of keep repeating the task and keep saying, is it ready? It's not really efficient. It's not nice to write code this way. But what we actually want to do is we want to have a nice way to say, hey, kitchen, I would like to have this food. And then once the food is ready, I am going to deliver to the table. And that's where the then comes in. We can say, okay, we get back something that says like, yeah, I will prepare it. So we get back like this promise object. And then I can say, okay, once that is ready, then when you give me the food, I'm going to do something. I'm going to deliver to the table. So in here, there's also a new task. But now this is not added because a certain time is passed, but the task will only be put on the queue once the chef, like an external parking, which like will be your browser in real JavaScript, put it on the task. So it's not there until it's actually ready. Once it appears, I know it either succeeded and there will be like a happy face and there will be food, or there will be like a very sad face that says, oh no, we ran out of ingredients. So either I go to my den or I go to my catch, but it's only after the thing resolved. So I don't have to start pulling. I know once I receive the task, it's ready. And this way we can actually coordinate larger things because I can say, I get the order, once I get the order, then I'm going to deliver them drinks. Once I get the drinks, then I'm going to ask for the food. Once I get the food, then I'm going to give it to the table. And once they finished eating, then I'm going to deliver them the bill. So you can really, this is how you can schedule like the dependencies like you asked earlier. You don't yet know when this task is going to be available, but once it's finished, I'm going to do something else. So that's really the idea here of the .then is because you want something to happen after another thing has happened. Okay.
Yeah, so the set time.
The time on the time. This is better coding.
Yeah,
yes.
This is better.
Yeah.
The promise is better than the set time.
Yeah, the set timeout, you can, we only use it kind of as an example to show you guys what is asynchronous programming. This is what you use every day because with set timeout, you always have to define yourself how long something is going to take. And in the real world, you kind of never know how long something is going to take. It also depends on how powerful is your computer, how good is your internet connection. All those kind of things, they vary, so you don't know when a task is going to be completed. So you use promises. You just say, okay, handle it. As long as it takes, doesn't matter, but I can keep on doing other things. I can keep on rendering stuff. I can work on other tasks. I can do whatever I want. But at the moment that it's ready, I give it this function, this callback, and at the moment it's ready, go do that. And this is again the queue system that is working.
Also, for example, I might have given 4 different orders to the chef, and like it's whatever the order that is finished per by the chef that we're going to execute next. I don't know which is going to be the next order that is available. I just know once something is available, I can do the next step on it. There's also a question in the chat. Maybe.
Oh, okay, wait, I will check. Please stop sharing. Oh, yeah. Yeah. Yeah, he knows better than me. So, yeah, there's also an important point that it doesn't matter in which order it's not like synchronous programming. It's whatever is done first gets back to you first. It doesn't matter how you put it in your code. This thing, I don't know if we can do something with this. This is sort of more an example. Let's see what the other examples have. The function returns a promise.
The view? What happened? Oh.
The view? I didn't like. So yeah, in this example, now in the last example, we created a promise ourselves with the new promise, but you can sort of create a constructor for this kind of thing. We create a function that returns a promise. So what you're doing here is attaching a function to a promise that will deal with the resolve or reject logic. So this is the thing that will, if this is finished, it will sort of say when the callback can be launched and which callback. Is it the success one or the reject one? That is this logic. And then you can reuse that in any way you want. So you can reuse the sort of same logic here to create all these promises. So you can return a promise just like any other function, really. I don't know what's maybe another point. Oh, there's something in the chat again.
No, we're just looking around.
Okay. Okay, let's see what else is in here. A delayed promise. Yeah, this is maybe a good thing for you guys, maybe start experimenting later on with. We saw the set timeout thing. You can use a set timeout in a promise to sort of, let's say, reenact the way a promise could work. So like in the real world, you don't know, like we just said, how long a task is going to last. But with set timeout, you can say, you can define it exactly. So you could create a delayed promise with a set timeout inside it. So the thing that you see here, you could give it a random value sort of to emulate an API. So let's say you don't know, maybe the API will take between 200 and 500 milliseconds. You can randomize this number and then you get sort of realistic replies. And then you can just say, okay, every time you execute this promise, take a number between 200 and 500 randomly, and then give me back some sort of array or an object or something that I can use in my page. This is a good way that we will also see later to, let's say, simulate the working that you're going to a backend to request some data. You can do this on your own with a set timeout to sort of see how promises work and how, again, the event loop kind of goes. So what we're doing here is you give it two parameters, a delay. This one gives you a delay every time. So here it's going to wait 100 milliseconds, here 50, and here a full second. And then another value, which is by default also delay. And then it will resolve this after the delay has come with the value you have set. So this is actually sort of a callback in a callback in a, which can happen, which is also a thing that, yeah, with this notation, it's perfectly possible to have multiple bends. So you can have a promise in a promise in a promise in a promise, a thing that is also known as the callback hell, actually, because, yeah, the first promise executes, but it doesn't know when the next task is going to be, so it can keep on going and keep on going and keep on going, but maybe this task is already no longer relevant. So you don't really, so you have to be sort of wary, and you kind of have to know what you're doing when you start to put callbacks and promises and promises. I don't know, maybe that's too early to go into sort of strategies to avoid that. But know that you can do this. Okay. I'm gonna see. Maybe this is a good time to do some sort of exercise.
Let's get back after the break.
Oh yeah, but first do a break. Okay.
Yeah.
All right. Let's take a break.
Let's start with the-